what are the building blocks of the digital circuits. So basically, if we beginning with the basic gates, which of course are very simple and you would have done in your even +2 level classes. So there, I mean, one of the simplest gate is NOT gate. So basically, why we need these gates? I hope you remember that in previous classes we talked about ones complement, twos complement, processing various numbers, doing arithmetic operations with the help of binary numbers. So at certain situations, we may actually need to play with the digital data. Means we may somewhere require to convert zeros to ones, ones to zeros, and so on. So in all those situations, what we do in terms of hardware, we actually employ a NOT gate. So what is a NOT gate is, I think we had already discussed it in previous class as well, one of our beginning classes, that a NOT gate is the one for which if you input high voltage or input 1, then the output is going to be 0. That is what a NOT gate is. Means it sort of inverts the input. If input is 0, output is 1. If input is 1, output is 0. And then there is something called symbol for a gate. So for NOT gate, the symbol is given by this particular symbol, right? So a triangle with a dot at the end. In some cases, this triangle is even removed or ignored. Actually, even a dot is sufficient. For example, in many digital circuits, you would notice a circle appearing. So that would actually mean a NOT gate, means the input being inverted. So low being changed to high, high being changed to low. But okay, I mean, as a part of, you should say, academic discussion, you should remember or know what is the symbol for a NOT gate. So here is, this is representing a input for the particular gate. So here is A is represented as the input, C is the output. And then there is something called Boolean expression. So Boolean expression for NOT gate is, say this is output is equal to input bar. So input bar means inverting the operation. I mean input inverting this number. So if it is high, it is changed to low, and if it is low, it is changed to high. How does this circuit operate? I hope you have studied the operation of transistor as a switch. So what happens whenever you input? So this is what you can call common emitter configuration of a transistor. This is emitter, this is base, this is collector. So collector is at high voltage, say +5 volt. So whenever input here, say A, here is high. Let us say A here is low, that is 0. So what will happen? Our base emitter junction is not biased. So base emitter junction is not biased means, so okay, what kind of transistor is it? First of all, you should we should notice it. So what kind of transistor is it? Can anyone let me know in your comments? What is this transistor? Is it PNP or NPN? NPN, sure. So this is a NPN transistor. So means if at base we apply some positive voltage with respect to emitter, so what will be the case? Then base emitter junction will be forward biased. And if the bias voltage is high enough, then what will happen? This transistor will be derived to saturation state, and it will be acting as a kind of closed switch. So what will happen whenever voltage here is high? This will be acting like a closed switch. So what will happen? What will happen is that this Y, here it is C actually. Okay, so C equals Y. Please don't get confused. So the output actually is the value of the voltage which is at ground. Why? Because this is as if transistor is acting like a closed switch. So if you connect a wire between this point and this point, what will be the voltage here? That will be 0 or the low. And the whole potential difference will be across this resistance, or the potential drop will be across this. So the potential at this point will be 0 and potential at this point will be 5, and the whole potential difference will be I into R. That will be across this resistance, because there is no other resistance. That is how when A is high, means 1, the C or Y will be 0, this part. Then when A is 0, means low, then this emitter base junction is not biased, or it is not forward biased, or the bias voltage is not sufficient enough to drive this transistor to saturation state. In that case, there will be a very low current, or practically, I mean theoretically, it will be negligible current. And if no current flows through this resistance, what will happen? There will be no potential drop across this resistance. And if there is no potential drop across this resistance, what will be the potential here? It will be exactly equal to this value. If current is 0, no potential drop across this resistance, so potential here and potential here will be exactly the same. And hence that will be nothing but 5 volt. So that is how this simple circuit can be used to make a NOT gate. So this explains NOT gate, simple transistor based circuit for a NOT gate, and symbol of the NOT gate. This is called truth table. Truth table tells us the relation between inputs and outputs. So how are the combinations of input related to the output values? That's what we call the truth table. So in digital circuits, truth table is a very important aspect. And then Boolean algebra helps in understanding the circuit and how input and outputs are related to each other. So, well, second basic gate is AND gate. I hope you have already done this, but okay, what is the second basic logical gate is AND gate. So sometimes we may require to do AND operation. And what is the AND operation? If we look in terms of, okay, truth table, and this is the circuit symbol for AND gate. So this is a 2-input AND gate actually, but it is not necessary that we always have only 2 inputs. You may have more than 2 inputs. So if there is another input, we may put here C, D, E, and so on. So this is called AND gate. And this is what we call the Boolean expression for AND gate, A and B. This is read as AND, or A dot B also you may say, but this is A and B. So output Y here is A and B. So what is the basic operation of this gate is that, okay, whenever A and B are 1, output then only will be 1. Otherwise, if any one of these is 0, output is going to be 0. That is why it is called AND gate. Means output is high only when A and B both are high. That's what is the reason why this is called AND gate. So again, I mean, how this circuit do operate. So operation is simple. Again, we have 2 NPN transistors connected in series, and A here is acting as the bias voltage, right, for the transistor, rather a base, emitter base junction of the transistor. A is the bias voltage. Now again, same thing, if you put A is equal to 1 and B is equal to 1, when both are 1, what will happen? Now here notice that resistance is placed here, not here. So try to not get confused. In NOT gate, the resistance was placed here, right? And in this AND gate, the resistance is here, and this will make things a little different. How? Okay, so if A is, so whenever both transistors are off, let us say both transistors are off, 0, 0. Let us say A0, B0. So what will happen? This is open, this is also open. So this is as if open switch. So no current flows through this resistance because these switches are open, not closed. So no current flows means there is no potential drop across this resistance. And whatever is the voltage here will be the voltage here. So what will be the voltage here at Q, or you can say output Y, whatever you want to name. What will be the voltage? Voltage will be 0 because voltage will be same as the voltage at ground. Now, if you make any one of input 1, either say let us say A is 1. Whenever A is 1, this transistor will be turned on, because now emitter base junction is forward biased. But only this transistor is on. So if you measure the voltage here at this point will be 1 or high, that is 5 volt or VCC, whatever it is. So voltage here will be VCC, but here it again is 0, because this transistor doesn't allow any current to pass through it, because B is still 0. So in that case, there is no potential drop across this resistance, and hence again the output will be 0. Now third case, when this is 1, this is 0, same thing happens. When both are 1, what will happen? This will be closed switch, so the current will be flowing through this transistor, this also through this transistor. And what will happen? These two are now acting as a closed switch. It is as if somebody has connected a wire between VCC and this point. So now what will happen? There will be a flow in current. There will be flow of current in the circuit. And of course, current will depend upon what? What is the value of this resistance? So current will be equal to VCC over R2. And hence, what will be the potential drop across this resistance? That is going to be equal to nothing but VCC, because here it is like a closed switch. So total potential drop across the resistance will be VCC. Hence, what will be the output? So here the voltage is 0. What will be the voltage here is VCC. And that is how, if A is 1, B is 1, output will be 1. So this explains simple working of AND gate. I hope this is clear. I mean, it is very, very simple and straightforward. But still, if any one of you have any question from this part, please feel free to ask. If there is any question from this part, yes, please. I am audible there. Any question from anyone? Am I audible, or all of you have left your phone somewhere and are sleeping? Huh? It takes a very long time to respond. Okay, meanwhile, you also sign your attendance, then response is very fast. You sign in your attendance so that, okay, it is recorded here. Then next is OR gate, and well, Boolean expression for OR gate is A or B, A plus B, that is how we write it. And again, this is the expression for OR gate, A or B. Now, what will be the truth table? So now, I mean, okay, what is the truth table as such is whenever either A or B is 1, output will be 1. That's why the name OR. Either A or B is 1, then output is 1. Otherwise, when both are 0, output is 0. So, well, how to design such a circuit? So this now, same circuit, which was used for AND gate, with small tweaking, very small changes. What we did is, okay, we gave VCC directly to both the transistors, A and B. Collector of both the transistors are connected to each other, and then to VCC. And emitter of both the transistors are connected at output. So emitter of T1 and T2 both are connected at the output. So now what will happen? Whenever any one of the transistor is in on state, there will be a flow of current through this resistance, and hence there will be a potential drop across this resistance, and that is why output will be accordingly 1 or VCC. So that's what explains OR gate. I mean, either A or B, if any one of them is 1, output is going to be 1. So that's the simple operation of OR gate. Again, I mean, there is one small component in your syllabus, that how we can design various gates using transistor and diodes. So we already discussed how transistors can be used to design these basic gates. Now let us discuss how diodes can be used to design the basic gates. So this is the first simple circuit which is designing AND gate with the help of diodes. Now you should note the circuit here. Let us try to discuss the operation of this circuit. So what does this circuit do? Here is output, here is ground. Well, here is the high voltage. So whenever A is 0 and B is 0, both of them are 0, means there will be, this diode will be forward biased. Why so? Because there is a positive voltage here. This is P section of the diode. This is N section of the diode. Now this N section is connected to the ground, right? Whenever N section is connected to ground, this will be closing the circuit via this route. And hence, what will happen? Current will flow through this resistance and there will be a potential drop across the resistance. So if here the voltage is VCC or V high, let us say, so there will be a drop across this and here the voltage will be 0 or at least very small, which is equal to built-in voltage of the diode. So whenever A is 0 and B is 0, both are 0, what will be the output? Output is going to be 0. If you make any one of them high, suppose let us make B is equal to high. So what will happen? N part of this diode is at high voltage, say VCC plus 5 volt. P part is also at VCC, right? But no, not so. This is at high, then this N section of this diode is connected to the ground. So the current actually will be flowing through this. So what will be the output here? Again, that will be low, 0, because current is flowing, so there will be a potential drop across this resistance. So output will be here 0. Now you will say, okay, what will happen to this diode? So here the voltage is high. That means, and here the voltage is low. This means as if this diode is reverse biased because N junction is at high, P junction is at low. So this is reverse bias, so no flow of current through this diode. Only this diode will be in saturation state and there will be flow of current, and hence output here will be low. Means whenever any one of the diode is at, whenever N channel of any one of the diode, then output will be 0 here. Output will be 0. So that is what explains the AND operation. Means for making output to be 1, both A and B has to be high. So whenever B is high as well as A is high, now here towards P channel, P end of the diode, voltage is say plus 5 volt. Towards N end of the diode, again the voltage is say high, means say suppose plus 5 volt. So there is no flow of current. So there is no drop of voltage across here. So whatever is the voltage here will be the voltage across here. So whenever A and B both are equal to 1, output will be 1. And that is how we can implement AND gate using diodes. Is this clear? Or any question from this? Some student, I don't know who is it, maybe Tanvi or what, saying was unable to see your presentation. Is the presentation available, visible to your screens or not? Presentation is visible? Okay, fine. So Tanvi, is it Tanvi who is sending me message, or who is it? Tanvi, is it visible now? Okay, fine. Maybe some network issue was there, maybe from your end or my end, whatever. Well, so is the operation of AND gate with the help of diodes clear or not? Operation of AND gate with the help of diodes, is it clear? Okay, if it is clear, then how can we design OR gate with the help of diodes? Here is the circuit. Now you take some time, I won't explain it. Try to visualize it in your mind how this circuit must be working and how it gives you OR operation. Then if you are able to understand this, well, if you are not able to understand this, you please type your question in the chat box. I will plan my explanation according to your questions. Yes, think over it and try to convince yourself if it is okay. I mean, will this circuit give us OR operation and how it will give us the OR operation? Is it clear? Can you understand how this OR gate or this circuit of two diodes is acting like a OR gate? Is there any question? Yes, please type your questions if any. The operation is very simple. If both A and B are 0, suppose A and B are 0, means at low voltage. So means this end of the resistance is at low voltage. This end of the resistance is also at the low voltage because both the diodes are at 0 volt. So the potential difference across the diodes is 0 and hence no flow of current, and hence whatever is the output here will be the output here and output will be 0. So when A and B both are 0, output is going to be 0. But when now suppose B is kept at 0 but A is raised to high, that is 1. So when A is 1 means high voltage means say suppose plus 5 volt. Then when this is plus 5 volt, what will happen? This P terminal of the diode is at a higher voltage, means this diode is forward biased and hence a current will flow through this. And whenever a current will flow, what will happen? There will be a potential drop across this resistance. Means if the potential here is 0, potential here will be high or VCC or plus 5 volt and hence output will be 1. So whenever A is 1 or B is 1, output will be 1. And when both are 1, again output will be 1. So this is what explains the simple operation of this OR gate. Now try to see this circuit, NOT gate using diodes. Try to see this circuit as a operation of NOT gate. So I mean, what will be the voltage here is important. So if output is 0, what will happen? This diode will be reverse biased because here is plus 5, here is minus 5. Here is 0. I mean, here is plus 5, here is 0. So what will happen? There will be reverse biasing, hence no current will flow. So whatever is the voltage here, okay, I mean, okay, its operation can be understood with the help of whether the diode will glow or it will not. So if it is 0, the diode won't glow, right? And whenever it is high, the diode will, just a moment, no. What will happen whenever this is at 1? So this is some sort of LED actually. Diode means light emitting diode, but I'm saying glow means it is an LED suppose. Whenever I connect it here, then voltage here is plus 5 volt. And towards this end is also 5 volt. So what will happen? Diode won't glow. There won't be any flow of current and hence there won't be any voltage. So whenever this will be high, there won't be any forward biasing of the circuit and hence there won't be any what you can call biasing voltage across this and there won't be any light emitted by this circuit. So means high means no light, means sort of 0. And whenever it will be low, then there is a inverter here. This is actually inverter circuit. So inverter circuit means then you may find out, I mean, okay, there is some problem here. this, whenever this is at logic 0, then what will happen is that this will glow, but how will this glow is confusion. Okay, I'll be clearing this circuit in the next class. There was some confusion at the beginning as well. So diode can be used to get a NOT circuit as well, NOT gate as well. But this is not properly, I mean, I won't be able to properly talk about this because there is some confusion out here. Because when this is 5 volt, this is also 5 volt, there won't be any current, of course, that is fine, this will be 0. Means no light emitted from this. But when this is 0, what will happen here? This will be 0 because this is N junction, right? If N junction is plus 5 volt, here we are saying 0, that won't be helpful anyhow. So need to check this. Okay, I mean, but the main message is, this I will talk in the next class. Main message here is that we can even get NOT gate, OR gate, AND gate all with the help of diodes, and they can also be obtained with the help of transistors. So basic circuits, how we can obtain AND gate, NOT gate, OR gate with the help of diodes or transistors is done. Now there are other set of gates as well which are very popular, and we call them as NAND gate and NOR gate. Now why these gates are simple and popular actually is going to be clear shortly. So first, let us first understand what is NAND gate or NAND operation. So NAND operation is nothing but AND gate followed by a NOT gate. Now you can see NOT gate here is written like a simple circle. So NAND gate is nothing but AND gate followed by a NOT gate. What is the Boolean expression for a NAND gate or a NAND operation? That is A and B whole bar. This represents the Boolean expression for NAND gate. What will be the truth table then? Of course, it will be opposite of, inversion of the AND gate. I hope you know what is AND gate. If A 0, B 0, what will AND gate give? 0. So what will be NAND gate giving you? Input of NOT gate when it is 0, output will be 1. So 0, 0, it will give us 1. 1, 0, again, output of AND gate will be 0. So output of NAND gate will be 1. So this whole thing will give you truth table for NAND gate. I'm sure it is very simple and straightforward. So there is no point of confusion here. Similarly, NOR gate means OR gate followed by NOT gate is what constitutes an OR gate. And same cheese, truth table will be like, okay, if you put OR gate here, output of OR here, then that output inverted will give you NOR gate. So what happens in case of OR gate? When both are 0, output is 0. So output of NOR gate will be a complement of it or inversion of it, that is 1. Every other combination gives us output of OR gate as 1. So output of NOR gate will be 0. That's what explains the NOR gate. Now you should ask a question which is very, very important and rather logical as well, and very much expected, that when we had 3 fundamental building block of digital circuits, that is AND gate, OR gate, NOT gate, why we needed these gates? Because ultimately what is a NOR gate? It is coming from OR gate and NOT gate. So it is nothing but some combination of those building blocks. Similarly, what is NAND gate? It is combination of AND gate and NOT gate. So nothing very new. The basic building blocks are the same. Out of those 3, only we are getting this gate. But these gates, whether NAND gate or NOT gate, both NAND and NOR gate has a very great advantage, that these can be further actually the basic building block of all the digital gates. You take only NAND gate. Suppose somebody provides you only NAND gates, one sort of gate, that is NAND gate, and asks you, can you derive any digital circuit with the help of only NAND gates? Yes, then you should say yes, you can get it. Whereas in case of NAND gate, NOT gate, and OR gate, you need 3 different types of ICs or IC circuits. So 3 different types of IC circuits. Even if a single is missing, you may not be in a position to get certain digital logics. But with the help of these NAND and NOR gate, you can actually design any operation by employing only either NAND gate or NOR gate. So how can we do this? Let us try to first understand basic operations from the NAND or NOR gate. So first let us discuss NAND gate. How can one obtain NOT gate from a NAND gate? This is very simple. You take a AND gate, two input AND gate, short both the inputs and make them to look like a single input, and then operation of such an AND gate will be nothing but operation of a NOT gate. Why? Because whenever this input, let me say X, is 0, then both A and B are 0, and what will be the output of the AND gate? That will be 1. Both of them, when X is 0, A and B both are 0, so output of AND gate will be 0, but output of NAND gate will be 1. So it's like something similar to NOT gate. Similarly, whenever this is 1, both A and B are 1, output of AND gate will be 1, and output of NAND gate will be 0. So this is how we can get NOT gate from NAND gate. Very interesting. Then how one can obtain AND gate from NAND gate? So AND gate can also be obtained from NAND gate. This is rather very simple. You take a NAND gate, because NAND gate is nothing but AND gate followed by a NOT operation, right? So you put another NOT gate which you designed in the previous slide after this. So NOT of NOT will be the output itself. Means complement of 0 is 1 and complement of 1 is 0. So complement of any output or input will be the input itself. So that is how we can get NAND gate, AND gate from NAND gate. Means NAND gate can be used to design NOT gate or AND gate. Now the question is how we can obtain OR gate from NAND gate. So OR gate can also be obtained from NAND gate by following this simple circuit. Now you can try to see the operation of this. Let us make a truth table in our notebooks. I recommend you to open your notebooks if they are not, probably, although they should be open, and try to make 3 columns. Let us name this first input as A, second input as B, this input as C here, this input as D here, and final output as Y. So you have 4 input columns and 5th is the output column. So this is A, this is B, this is C, this is D here, this is Y. Now let us take different combinations. If A is 0, B is 0, what will be C and D? If A is 0, B is 0, what will be C and D? Yes, please. Write down your answer. C is equal to what? What is D is equal to? A and B both are 1. I hope you are getting what I am trying to ask and what I just taught you. C will be 0, D will also be 0. What is this? Okay, C is, what is this? Some are saying 0. Parikshit, will it be 0 or 1? Because these 2 gates, if you follow here, this gate is nothing but a NOT gate. This gate is also a NOT gate. So if this input is 0, this input is also 0. So now what will be output here is 1, 1. So output here will be 1. Now this is an AND gate again. Whenever both inputs are 1, 1, what will be the output of NAND gate? What will be the output of the NAND gate? Let us say Y. Y is equal to what? 0. Very good. So we got one column, one row for the truth table. Whenever A is 0, B is 0, Y is 0. Middle columns let us ignore for time being. Then let us now make A is 1, B is 0. What will be Y? So whenever A is 1, okay, A is 1, B is 0. What will be C and what will be D? First let us write down what will be C and D. So whenever A is 1, C will be 0. Very good. And D will be 1. So now C and D are 0 and 1. What will be Y? C and D are 0 and 1. What will be Y? Y will be 1. Correct. Very good. Similarly, if we interchange A and B, means make A0 B1 or A1 B0, output will be 1. And third case is, or last case is, A is 1, Y is 1. Sorry, A is 1, B is 1. When A and B both are 1, what will be the values of C and D? C and D will be 0, 0. Correct? If C and D both are 0, what will be the output? Y will be 1. And if you see this new truth table, this new truth table is nothing but the truth table of a OR gate. That is how we can realize OR gate with the help of Nand gate. So now what we have seen is that Nand gate can be used for constructing either AND gate or OR gate and even NOT gate. So we can say that taking these NAND ICs, you can get all the building blocks of any digital circuits with the help of only single type of ICs. Similarly, OR gate, now let us see OR gate as a building block. Now suppose somebody says, no, we don't have NAND gate, I only have NOR gate. Then NOR gate can also be used as a building block. So this is how NOT gate can be obtained from NOR gate. Operation is very simple. Let's not get much into that. Similarly, we can also get OR gate from NOR gate. Again, the operation is very straightforward, very simple. Let's not again get into this. And we can also get AND gate from NOR gate. So these basic circuits should be there in your mind. I mean, you should be aware of these circuits, that how we can build AND gate from NOR gate. So that's all for today, that how we can actually get all the basic gates from these. So that is why these NAND gate and NOR gate are also called universal gates. Why universal gate? Because by taking any one of them, you can create any basic digital or logical expression, or any Boolean expression can be realized by just employing NAND or NOR gates. Then there is something called XOR gate, exclusive OR gate, and XNOR gate, exclusive NOR gate. Then we will be discussing them in the next class, exclusive OR and exclusive NOR gate. And then some application of those exclusive OR and exclusive NOR gates. Well, then that will complete your first unit. Fine. I mean, if there is any question from what we did today, I will be happy to answer. Or any doubt, any concern, you please let me know. If there is any question or any feedback for what we did today. Yes. Waiting for your questions or responses. No? Well, if there are no questions, then thank you very much. And